This is the solution video for problem 2b. We've got a rational equation here with three different terms. As with all rational equations, first we need to find that least common denominator. I notice that two of the denominators are in common, so the way I'm going to find the least common denominator, just multiply the other two, and in that case the least common denominator is 4 times x minus 3. All right, that's a common denominator. Each of the three denominators will divide evenly into that least common denominator. Next, I'm going to rewrite the equation by multiplying each of its terms by that least common denominator. On the left side, I started with 3 over x minus 3, and I'm going to multiply it by 4 times x minus 3. On the right side, I started with x over x minus 3 as that first term. Multiply that by the least common denominator. And then I have this minus x over 4. And again, multiply that by the least common denominator. Next thing I'm going to do is look for some common factors that appear in the numerator and denominator that I can cancel. Looking over here to the left, I see that the x minus 3 can be canceled. Looking in the middle term, again, the x minus 3 term can be canceled. And here in the third term, it's not the x minus 3, but rather it's the 4 that I can cancel. A 4 over 4 is the same as 1, so I can just cancel those out. What am I left with? On the left side, it's 4 times 3. On the right side, I'm left with a 4x as the first term, minus x times x minus 3 as the third. All right, let's keep working on this to solve for x. On the left side, 4 times 3 simplifies to 12. I've got my 4x in my middle term, and here I'm going to distribute the x, and when I do that, I'm left with minus x squared. X times negative 3 is minus 3x, but it's negative 3x, but we're subtracting it, so it's really plus 3x. I can combine some like terms here. Actually, what I'm going to do, I'm going to get everything on one side, and I want to set it equal to 0. I like to do this for quadratics. Notice this is a quadratic because I've got a factor in here that's raised to the power of 2. So I'm going to add x squared to both sides. As a first step, when I do that, I've got x squared plus 12 equals 4x plus 3x. Well, we know those are like terms. Those can be combined to 7x. And I'm going to subtract 7x from both sides. That'll leave me with a quadratic equation, x squared minus 7x plus 12 equals 0. This looks like a sum product factoring method. So I'm going to go ahead and factor this. And when I do that, I see that 4 and 3 multiply to 12. And when they're both negative, they actually add to negative 7, which is what I need for this case. So I've correctly factored this quadratic, and I know that the two solutions then that make this equation equal to 0 are x equals 4. Right? If I plug in a 4 for there, that first factor becomes 0. And x equals 3. If I plug in 3 in for x, that second factor will be equal to 0. But now we need to check for extraneous solutions. So we have two solutions for this one, and one by one, we're going to see if either of those solutions makes a denominator in the original problem equal to 0. So here, let's take x equals 4. We can go all the way back up. If we plug in a 4 for x in this denominator, we get a 1, and that's okay. If we plug in a 4 for this one, same thing. We get a 1, and that's okay. So the solution of x equals 4 is okay. What about x equals 3? When we plug that in for x here, we get a denominator of 0. So x minus 3 does not work. It results in a denominator in the original equation equaling 0. Therefore, x equals 3 is an extraneous solution. So the only solution to this problem here is x equals 4. X equals 3 is extraneous.